Well, thank you very much, everybody, for coming today, and also to the SANS Summit team for giving us the opportunity to talk about our research. My name is Roberto Rodriguez, and I go by CyberWarDog in Twitter.
My name is Jose Rodriguez, and I go by CyberPanda, and if you haven't noticed, we are brothers.
And we also come from Peru, and all these projects in here are the ones that we've been working for the past couple of years, but now we're actually putting all that under one open public organization in GitHub, which is called the Hunters Forge. So if you can just do GitHub Hunters-Forge, you'll be able to see some of these that we'll be talking about today. So the agenda for today, we have a lot of things that we're going to be talking about. Hopefully we can pack all this in 30 minutes. But the idea here is to talk about specific projects that we've been working on, but also an open source tool that is allowing us to expedite our research and also allowing us to share and also replicate our work with others. So when we talk about threat hunting, there are a couple challenges, right, that we face. Some of you guys might have a lot of tools, a lot of data, dashboards, visualizations, just amazing stuff when you walk into your office. But not everybody's lucky as you. There's actually a couple challenges that are going to be companies deal with. Some of them could be organizational challenges. Some of them could be also data engineering challenges. But the ones that we want to talk about today are the challenges for us to first understand our adversary, try to build an analytic, but then also how we can start sharing all this research and tell the story about our analysis. So Jose and I put this together for a presentation before. You can watch the video at the bottom. And this is just a high overview, something that you can do from just identifying your research goal all the way to validating your detection model, and then pretty much to document the whole process. So today we'll be talking about these 4 steps. And we'll start by talking about a little bit of the simulation of an adversary. When we do this goes beyond just testing your endpoint agents. We're talking about companies or teams that actually collect that data and then want to complement that, that security control with their own analytics, because you want to understand the adversary. You want to start mapping data to specific actions that are being taken. So when you do this, right, this is not as easy as just downloading a script and then executing in your local VM and then just start from there. There are a couple of techniques that take more setup than that, right? A couple of techniques involve a lot of different things going on, such as Active Directory, different domain controllers, different forests and things like that. But at the end of the day, what I see a lot is that this is going to generate some data, right? You can use that to learn about the adversary, or you can use it to start even testing your current analytics. In my experience, this takes time, right? And especially when you start talking about variations of techniques, this takes even longer, right? But you got to start thinking about that if you start running all these different variations, there's going to be some similar events, right? And that's the goal, because we want to focus on the behavior. So for example, let's talk about lateral movement via WMI, right? We can use a couple tools, all the way from built-in tools, all the way to even tools that you can execute from non-Windows computers, for example. So if you run all of this, there's going to be certain behaviors that we'll be able to capture. In this case, we have a user authenticated from a source to a destination endpoint. That generates a network logon session on the destination. And anything that you tell WMI to execute, right, will be hosted by the WMI service process, WMI PRVSC. And anything that WMI PRVSC executes is going to be hosted or run in the context of that specific network logon session that was created when you authenticate. That's the basics of lateral movement via WMI from a detection perspective. And you can do this with telemetry that you have available in your environment, right? And once again, you're going to start noticing that once you run through all of this, once again, we're going to get to a similar behavior. So at the end of the day, everybody in the world, a lot of teams, different companies, different countries, right, are actually doing this, right? And they get, at the end, similar data, right? If you go through the same WMI activity, you test 20 different tools, the behavior is going to be a similar behavior that I just explained a little bit. Not everybody has the resources, not everybody has the flexibility, the expertise, or the tools to do this, right? So what if we start actually sharing our data sets? What if we just start standardizing an environment and start just publishing the data sets that we're working with? Well, that will take an analyst from zero right straight to the analytics piece of their research. And there is nothing wrong with this, but I want to expedite this process. And I want to make sure that I can have on-demand data sets that I can work with. And I can help analysts to start, use them directly. Instead of spending time trying to produce that data, they can spend time actually analyzing the data, which is the main goal at the end. So for this, there's a project called Mordor, and of course we loved a lot of the rings, so that's why it is the name over there. But this is something that Jose and I put together where we start now creating this repository of data sets that we can start sharing with anybody in a format that can be easily consumed, such as JSON, and you can just put it into your specific tools, analytic platforms, and also is categorized by the MITRE ATT&CK methodology, right, with tactics and techniques. But once again, we do not want to just do the same thing that we say not to do, which is just grab a script, run it in a VM, pull the data, and then share it with you, because that, to me, is not actually as prepared or robust to share. So we created some standards, some documentations, configurations that would allow you to understand why certain telemetry actually was created or why something is enabled. And we do this with a couple of environments that we call the Mordor environments. And we are going to have actually some telemetry being added later. So this is a project that is still in working stages. So the first one is the Shire. This environment, it's just a basic network environment where we have a couple of Windows workstations. We have a health instance that allows us to have some type of the analytics platform that we need just in case we want to just run some queries as well. And we have a tool that allows us to then replicate some of these techniques. The telemetry available here is Sysmon and also Windows security event logs. Beyond just security, we're talking about applications, system, and all that. We believe that this free telemetry is actually very rich and robust to start sharing a lot of different techniques as well. The way how we ship this, we actually do it via Windows event forwarding to an event collector, and then we use a log shipper just to send that to our instances for analytics. But at the same time, Health comes with a server called Kafka, and that allows me to store the events for a short period of time. And that's how I start pulling the data. We have another environment called Erebor. And for those that love Lord of the Rings, right, Erebor. That one it's also a similar setup, just with different domain name and different IPs. But the beauty of this is actually that we do have ETW events being pumped directly to the health stack. We use a tool created by Ruben Fuzzy Sec in Twitter from FireEye, and this guy is amazing. And he just put this tool, Silk ETW, that now is running as a service in this environment. It reads this XML configuration to enable ETW providers. Then it creates event trace sessions to subscribe to those event ETW providers. And then the Silk ETW service will collect that data in real time from those trace sessions, and then in real time also push it to an event log, something that is not by default available for every single ETW provider. And of course, once that becomes an event log, I can just use the same concept and send it to me to my health instance. I'm speaking Spanish and English at the same time. All right, how do you collect this data, right? Now you might be asking yourself, how do I actually pull it to a file? We use a tool called KafkaCat, and this tool allows us to import, to produce data, to publish data to a Kafka broker, and allows us to consume data as well. So if you want to consume data, all you have to do is run these commands. You point it to your health instance, and then you'll be able to set the tool in consumer mode, and then you tell it to start collecting from when you start the script, and then you can push it to a file. And I'm going to show you that in a little bit. So this video right here, first I can show you that I'm actually reading events from the Kafka broker in real time. And then I can use the same commands that I showed to you and push everything to a file. I can use a tool like Covenant, which is a C2 framework, and I can just run a basic technique. Here I'm just taking a stolen hash and trying to get a TGT out of it. This is called overpass the hash techniques. So once I do this, as you can see at the bottom, I'm collecting data. And once the technique is over, I executed successful got a TGT, I can actually now stop my collection and I can actually see if I can find some of the indicators that I was looking for as well. You can do a basic grep if you want just to start, but at least you were able to create that data set in real time in a few seconds. The same concept we use for publishing data, right? Now we are publishing data back if you want to use the data with another analytics platform. You do this by running these commands. The only difference is that you set the tool in producer mode, and then you point it to a file, and then that will take it directly to a Kafka broker, and you can just consume it from there if you want. But not everybody wants to do that, right? You might be saying, well, that's too much. All I want to do is just download every single file and just use it. I don't care about Kafka Cat. All right, cool. You can actually run these 3 commands in here, and you can actually download every single file, decompress it, and they will be available as JSON files in your environment, just like that in a few seconds. So we went from on-demand data sets that we wanted to have all the way to now having that data available for you, something that you can just start taking from this project and start running some tests.
So what if you already have analytics for every Mordor data set? Well, that means that you might be ready to start validating your detections using Mordor data sets. So if I were you, I would take every Mordor data set, run it through your analytics, and check if you get what you were expecting. Now, with Mordor, we have a lot of data sets, we have a lot of data. So now what? What is the next step with this? Well, actually, we can start analyzing our data in order to define more detections and document all the process behind this activity. Now, when we start talking about building detections, we also face challenges. That's why we want to be sure to use tools and apply procedures that will allow us to be more creative when querying our data and also be flexible enough to develop our own libraries, right, to feel more comfortable when analyzing data. For example, in my case, I like to use Python to analyze data, so I want to use tools that allow me to use this language. Now, at this point, something very, very important for us is the documentation of this process, and also be able to tell the story behind this analysis in an easy and flexible way so other people can have access, they can learn, they can replicate these, and also get the same results. Here is where projects like the Jupyter Notebooks come into place because they meet all these requirements.
So what are Jupyter Notebooks? And Jupyter Notebooks, think about it as just a document that you can access via a web interface that allows you to save the input, the commands, the queries that you run, and the output, the results of that execution of your query. But at the same time, you can actually save visualizations in any narrative text, anything that helps you to tell the story about the analysis and how you get there. The Jupyter Notebook project is the evolution of a project called IPython, which pretty much the basic idea was to take the Python interactive console and allows it to add some additional advanced data capabilities, data analytic capabilities through a web browser, for example. So how do Jupyter Notebooks work? And they follow this client and kernel infrastructure, and we're going to talk about it in a little bit. But the basics in here is it follows the user provides an input, the input gets evaluated, and then the results get sent back to the user, and then you continue doing this process for your analysis. So at the end, we have a client, such as a browser, just to access the Jupyter Notebooks server. The Jupyter Notebooks server will serve those documents, the Jupyter Notebooks, and you will be able to interact with something that is called the kernel. And the kernel has nothing to do with the operating system kernel. It's just the analytics piece of the Jupyter Notebook framework. In here, you can actually, the beauty of this is that you can actually have different languages that you can port over the kernel, because the kernel can actually utilize, for example, Python, R, PowerShell, different other analytics engines that you want to work with. That's the beauty of this tooling here. So you can try it at home, or you can do it in here if you're already in the Hunter's Forge GitHub. And what you got to do is you clone the Notebooks Forge project, and in there, I do have a lot of Docker servers already built for you. And I have one that is called the Jupyter Base. In there, what you can do is you're going to find a Docker Compose file, And in there, you can see that it's pointing to an image that I already built for you. All you have to do is run the Docker compose file, commands, and then this will be able to run this, download the image, and then just run it for you automatically. It might take a few minutes for you, but in here, all you gotta do now is check if it's running, and it is running, on port 8888 locally. But now you have to know, how can I now access this container? Well, you actually can run a command called Jupyter Notebooks Jupyter Notebook list, and that will tell you where this server is being running, and it will tell you the specific URL that you can use to just paste it on a browser. In here, it drops you directly in the Jupyter environment, and you can start building new notebooks. You can choose your specific kernel. In this case, we have our input, and our kernel is Python. So I can just run a basic print statement with the Ola Summit today, just to you guys. And then once this run, it's going to give me some output. And now I can continue my analysis. But that's just the basics of how you can interact with a Jupyter Notebook. So now this makes sense. We were able to get in a specific kernel, the Python kernel. We got a print statement, and we get some results back. Now, something that we want to emphasize is that when you are doing any of this, not just with Jupyter Notebooks, but you have to practice like you play, right? You got to practice like you hunt. So I like to use tools that I know are used at scale, tools that are going to allow me to be prepared for when, who knows, probably I'm working with an organization that has distributed data that cannot be stored in just one computer. I need to work with tools that allow me to understand that execution and how it starts to understand the data that way. And then at the end, I complement my analysis with a library called pandas as well. Now with the Mordor dataset, I can just easily grab this and then just start analyzing my data.
So we will be using the word data frame a lot in this presentation. So for us, it's very important to understand what is a data frame. A data frame is basically an organized way to represent data. You can think of a data frame as a table with columns and rows, where every column will represent event fields, right, from field name, sorry, from an event log, and every row represents an event with all its values. Now, let's take a look at this lateral movement via WMI technique that Roberto explained to us before, and we are going to use a Mordor data set for this, and we will analyze it using Jupyter Notebooks. But before this, just let me share with you guys that I created OpenHunt, a Python library, that will help us to expedite our data analysis. You can install it via pip or just straight from source. Now, let's take a look at this Jupyter Notebook. First, of course, we need to import our Python libraries. Then we initialize our Spark session to interact with the Spark libraries in order to be able to analyze our data. After that, we can import our Mordor dataset and expose it as a data frame. Now, before we jump into the data analysis process, right, we need to register our data frame as a SQL temporary view to run all these SQL queries. And we can start, for example, identifying what event log channels we have in this data set. I'm not expecting a lot of events here because, this is a small data set. Now, following the behavior of this technique, let's focus on authentication events from Windows Security 4624. We get information about users authenticating over the network. For example, we can see P. Gustavo is authenticating from that computer and that IP, and also we have the logon session the logon session ID value in that result. Now let's focus on the process creation events from Windows Security 4688. We will get information about the processes, then the parent processes, and also the logon session ID too. Now, let's take this value from 4688, the logon session ID, and let's join it with the other logon session ID from 4624. And we also need to add more context to this query, right? Because remember that we are looking for users that are authenticating over the network. That's why we need the logon session type number 3. And we are also looking for processes that were created using the WMI service process. So at the end of the day, we will be able to identify the behavior of this technique in our environment.
So here you can see the pretty much net.exe utility being used over the network via WMI to create a backdoor user, for example. All right, so let's take this now to another data set, right? This data set is the APT3 data set. We actually follow the APT3 emulation plan from the attack evals, round number 2. So that's with PowerShell Empire commands and all that. So we ran all this. We created the data set. We used the same concept as Kafka cat to start the collection and stop the collection. So if we look into this Jupyter Notebook, we're going to start doing a similar process, right? We import our OpenHunt libraries to allow us to query the data. We initialize our Spark session, once again, to access the Spark libraries to analyze our data. Then we import our data set, same with the OpenHunt library, and we make it pretty much available as a data frame. We're going to start the exploration of this, but before, we have to set it up as a SQL view so we can run some SQL commands. Identifying some event logs in here, I can expect more events than the other data set. Now, something that I like to do in here now is just to start exploring the data a little bit. And I would like to see processes being created. And I use this function, the time series function from the OpenHunt library, to tell me processes created over time. And I can see the counts of for example, from a bucket of 5 seconds, a time window. And I can see, for example, you can see all these names, but you can see a little image in there, like something that, there were a lot of processes that happen in that specific period of time. So I can just take the same query with the time series library, and I can just filter that in that specific time window. In there, I'll be able to identify that the red one was actually net.exe in that specific visualization. So I can now say, okay, let's just go a little deeper, and let's use the same query, but now let's try to focus on net.exe in the same time window. And I want to see the command lines and things that were provided with that utility. And I can see right away that it's a lot of behavior happening in that specific period of time, and based on my experience, this sounds like a password spraying through network shares, for example. And then if I go through all this data, I can see that this actually is password spraying, and it matches my playbook from the APT3 attack eval, for example. Then I can start thinking about some other things that I can do. What if I want to look at the whole time window that a process was alive? I can take a process creation and termination timestamp, run these two cells in Jupyter Notebook, and that would allow me to start creating a new column with those values. The specific time, creation and termination, the time window, how long was the process alive? And I could see that some processes, right, have a couple of 100 seconds. But now what if I want to look for processes that were only alive for less than a second? That could be interesting. I want to know if there is some type of either scripting capabilities or anything that happened right away. Why not? I can use now this query, and I can start looking for that specific behavior, for example. And once I do that, I can see that there is a couple of processes. Net.exe is there as well. sc.exe for services. It's interesting to me. Now, let's focus by using, for example, a bar chart visualization in here and get the average of these times per process. And I can just run this specific cell, and I can see now this in a visualization, and I can see, for example, the ones that might be also a little interesting. Let's focus on net.exe again. I want to make sure that I should be getting similar results as before. And when I do that with this query, you can actually see in here that net.exe would actually have a similar behavior as before, but this behavior follows on the time series over processes over time, also type of behavior, and the time that the process was alive. Let's look for some signs of lateral movement. Let's just do the same thing that Jose did. 4624 logon type 3, join it with the logon session ID with the 4688 event. I get nothing, which means that there might have not been processes that were created over the network. Let's look for any other event that can be joined with the 4624 logon type 3, and in here I can actually see a few other events. Some of these are more related to the authentication process that occurred, but then I ask myself, is this the only lateral movement potential event? Well, if I read my data dictionary, that's what is so important to understand your data, the subject logon ID for a lot of events is actually the main logon ID of the user that performed the action. So instead of joining on target logon ID for both events, I'm going to do target for the 4624 and subject logon ID for the other events. And I get some interesting events in there as well besides the other ones that I found. If I stack this with the function that Jose put together in this library, I can actually see some interesting events. And the one that I feel very interested in is 4697. For those that are also localholics, I guess, you can actually see that that's a service being installed. So if I focus on that now with the same query, I can actually see that this service was installed, Adobe updated. It's pointing to a specific script, but it occurred over the network. It did not happen locally. So that's the extra context that I will be able to find just by being able to tell the story like this. And I can tell you that I took the WMI lateral movement behavior and I adjusted it now to find other lateral movement behaviors by following the same techniques. And we found services installed now over the network. So would everybody understand our notebooks, right? Some of you might be saying yes, some of you might be like, I don't know about that. There was a lot of queries all over the place and like it's just too much. Well, this is what we like to do also. We like to document and standardize our notebooks. And we use this project, the Threat Hunter Playbook, to share our research and create a specific format to share this. So if you go to the project, you'll be able now to go to a folder called Playbooks, and you start looking for that lateral movement via WMI, for example, notebook. And you can actually see that there is a notebook in there that if you open it, now you will be able to have a specific format that we like to document all this. We have the specific name. We have some playbook tags, so we can join it with other playbooks. Some attack tags, right, to categorize this playbook. Some technique description. I want to tell you what this is about, but also I don't want to give you 20 different pages for this. I want to give you some extra reading links to keep it clean. I like to put the hypothesis, the data sets that help me to validate these analytics, and also the specific events that I use for the analytics. And then I can start sharing pretty much what Jose put together, and I can start even adding more comments to that. Each analytic now has a false positive rate. Now it has some high fidelity, low fidelity. You can just be creative. But then at the end, I can tell you the whole story, how we got to the specific join of 4624 logon type 3 with WMI PRVSC creating processes under the same logon session, right? So this is the beauty of having this type of projects. Now the question is, are you ready, right? We have all these resources. You have all these different things going on. Well, so what can you do with that? Here's where the announcements are going to happen with the Hunters Forge community. Jose and I are founding this community because we believe that we have a lot of content that we can start sharing in a more standard way and that we can start helping others as well. We are actually making our Slack channel public. This has been open privately because I didn't know how to set it up public. That was actually the only reason why. But now I can actually have it ready for anybody just to go to that link and you can get an invitation for that. And I'll share the link in a little bit as well. Now, remember this initiative, right? Sharing Mordor data sets, sharing just data so you can go straight to the analysis piece of your research, right? What if you also get a Jupyter Notebook server with that? Now, you might tell me, wait a minute, okay, are you talking about Docker images again, like trying to make me download them locally? No, it's a little bit different in here. We use a project called the Binder project. This project overall allows me to start, they actually allow anybody to use open infrastructure to start sharing your research. And they put together this project with a specific tool called Binder Hub. This tool automatically, for free, allows you to put all these services together that they manage, and they allow you to start building your own Jupyter Notebook servers to be able to share your analysis with the world. The way how this works is you can actually have you go to the Binder site, you point it to a repo, and you tell it how to build the server. I already built this with Docker images, so I can just have the Threat Hunter Playbook Docker GitHub repo, and then send it to Binder Hub. Binder Hub sees if the project exists in their services. If it doesn't, it will build the repo to Docker libraries. And then we'll be able to access that Jupyter server automatically through the website. Now, if it exists, but I updated certain playbooks in my GitHub repo, they will rebuild it for you again. That's pretty much how it works. So at the end of the day, I can have open infrastructure for open hunts, right? We want to be doing this where we start collecting our 300 playbook project with our playbooks and research, and then also put it together with the Mordor datasets as well, so you can interactively play with them. So we're going to do a quick exercise. For those that have a computer in here, we can do a live, actually, the first time that I've seen a live hunting engagement here. But pretty much you can go to this link, or you can go to the 300 playbook, and I'm going to show you how this actually works. So if you go to the 300 playbook and you scroll down, there is a logo there, and on the top of that, there is a specific badge that says Binder. If you click on it, it's going to start going through their services and trying to find the Docker image that I had already created for you. And as you can see, it found it, and now it's launching it. And I didn't actually edit this video. That's how fast it is, where it actually goes and shows you the Jupyter Notebook. Now you have Mordor datasets, and you have Jupyter Notebooks available for you to interact. Let's look at WMI, for example, if you're following this. We can start getting the same format, right? Standardized way to share our research, format that you can use as well, showing you some of the description, some of the data sets that you'll be working with, and then some of the also events that were involved in here. Now you can take everything that Jose did and interactively shift, enter, going through every single cell, and you'll be able to pretty much interact with these data sets in real time through a web browser. And you can actually, once again, have all this documented, but we can share and validate that our analytics work, and you get the exact same results. As you can see, interactively, we can actually share this and pretty much show you the same join that we provided, and we can start sharing this specific WMI through lateral movement via WMI to create a backdoor user via the net.exe utility. Isn't that so cool about that? So
using the Binder project is super cool for us because now I get a notebook.
Roberto
gets a notebook. Everybody gets a notebook now.
Playing the opera thing here. So the goal with this is actually to share as much as we can and also empower the community. We want to make sure that we can provide resources to anybody in the world that wants to start playing with this, that might not have the team, might not have the expertise, might not have the resources to be doing all this. You can access Binder through anywhere in the world. They actually have hubs in different continents where the data is actually faster even to load. So we put all this together for you guys, but at the same time, we cannot do this all by ourselves. Right now, this whole community is just an army of two, but we have a lot of projects in there that if you want to contribute, if you want to talk about it, we can actually start having these conversations. All these resources, it's pretty much will take you and kind of like allow you to keep these conversations with us. And if you go to the Slack invitation, you will get your, of course, automatic invitation. And before we say anything else, thank you very much for your time.
Muchas gracias por su tiempo.
Appreciate it. Thank you.